Hello guys, welcome to the series Solving Erdős. So there are a few numbers on the screen. Can you find any relation between all of these? So the thing is that all of these numbers are the same numbers written in different bases. 21845 in base 10, 5555 in base 16 hexadecimal, 52525 in base 8 which is octal, and the top one in binary which is base 2. There is another interesting property about all of these numbers, which is that these three are palindromes. Palindromes are a number in which the number is symmetric about the center. So 52525. So it starts with a 5, ends with a 5. Also, this 2 is also mirror image of itself. Same with the binary representation, the octal representation, and the hexadecimal representation. So today's problem revolves around such numbers where we have to find the sum of numbers which are less than equal to 10 to the power 9, which are palindromes in binary, octal, and hexadecimal base. So this is a problem solved by 241 users, which is a good amount of users. So it can be classified as a low to medium difficulty level question. So the issue with brute forcing through all the 10 to the power 9 numbers is that it can take a lot of time. So we can use a property of palindromes to make it a lot faster. Let's say we have the number 100001. It is a palindrome, but if we write the number 100, we know the next half has to be 001 for it to be a palindrome. So we can use this property by just using the first half of the numbers and then constructing the next half using the first half of the number. So instead of 10 to the power 9, we'll have a lot less computation since we are just directly halving the digits. One more thing to note in mind is that using the number 100, we can also create the palindrome 10001. So the thing is that we'll have to keep this in mind smartly and change the loop such that we construct both these palindromes with the number 100. So this would be for all the numbers where we'll have to first write the number, mirror it, and then we'll have to check another number using this number, which has to be the number, its mirror, and the digit in the middle. We can just remove that. So iterating through this gives us a lot less possibilities to iterate through, and this would make our solution a lot faster. So let's try this out in code. I'm doing this in Python because we'll be using strings and manipulating strings is a lot easier here. So moving to the code part, the first thing which we need to know is that we need the sum of all the numbers. So we'll just use a variable answer and print it at the end of the code. So for iterating through the numbers, since this is a 10-digit number, we'll use only half the number of digits we need to calculate all the numbers, which would be 5. So just 10 to the power 6 should be enough for us to cover through all the numbers which are less than 10 to the power 9. So constructing the variable j for now. So let's construct the variable I for now, where say the number which we are dealing with, the number j is 100. We need to construct a palindrome with this, which is I, such that it is the number plus the reversed part of the number, which is 100001. So what we can do is we can take the binary value of j, strip out the 0b part which Python assigns to it, and this plus is a string addition. So it basically does 100 plus 001, which would give 100001, which is in string. So the same number, and this is used to reverse the number. So we need to convert this number I to decimal. So I'll write a short code to convert that. So yeah, now we have the decimal representation of the number I, which is a palindrome in binary. So before adding it to the answer variable, we need to check whether firstly it is less than 10 to the power 9, and then we also need to check if it's a palindrome in the three number systems. So the thing to note here is that we have constructed X in such a way that it is a palindrome in binary. So we need to check for octal and hexadecimal number systems. So what this does is this converts it to an octal number. It strips out the 0 part which is in front of the number, which is not desirable, and checks with the reversed version of the number. So if a number is equal to the reverse of its number, it is a palindrome, as they are mirror images. So this part does for the octal number system and this for the hexadecimal. And if all of these conditions are true, then we know that it satisfies all the conditions which are in the question, and hence we add it to the answer. But one case which we are missing right now is from the number 100, we can also construct the number 10001. So we are reversing this and stripping out the middle part and like adding it just once. So what we can do is take all the numbers from the binary value of j except the last one, which is this, and then add it with the reversed version of binary of j. So since most of the code is written, I'll copy it and use the same code. Since the logic is same, just the number I has changed. So instead of the whole thing 100, we just need the uh, number minus its last digit. So we'll include the number till its last digit. So this does that, and this should be enough for us to get the answer. So yeah, some slight error there. So yeah, running the code in about 16 seconds, we get the final answer, which is this. This might not be the most optimized code which I've written, but yeah, it does the job. And you can see if we would have iterated through all the 10 to the power 9 combinations, this would have taken roughly around 1000 times more time, which is not ideal. So we'll try to submit this to the website, and indeed the answer we get is correct. Thank you guys for watching the video. That's it for today. If you like solving difficult math problems, please consider subscribing and following my socials. The links are in the description. And if you need the solution to any of these problems which I've solved, I have a GitHub repository which I have linked below, which is obviously free to everyone. So yeah, thank you guys.